All right, so let's go. We're going to figure out, let me just insert this picture right here. We're going to figure out from my desktop the special relationships between a 30, 60, 90, sorry. And so here's the picture just so that we have it to reference if we need to. So please remember that in the first situation, this side, this was a 2 by 2 by 2, so the hypotenuse is 2, and the short side is 1. So this would be 2 squared minus 1 squared, which is 4 minus 1, which is the square root of 3. And then this was a 4 by 4 by 4. So the short side is 2, so this would be 4 squared minus 2 squared, which is 16 minus 4, which is the square root of 12. And 12, remember, has a perfect square in it. So it's 2 square roots of 3. And then the next one was a 6-sided, so the hypotenuse is 6 and the short side was 3. So this would be 6 squared minus 3 squared, which equals 36 minus 9. Um, 36 minus 9 is 27. So it's the square root of 27, which is 9 times 3, so this would be 3, square root of 3. And the last one was, had a short side of 4 and a hypotenuse of 8, so 8 squared minus 4 squared, which equals the square root of 48, which is 4 square roots of 3. Okay, so let's look at the relationship. So if it was an equilateral 2 by 2 by 2, the long leg is the square root of 3. The short leg was 1, and the hypotenuse was 2. So please note, if there's nothing there, there's an invisible 1 here. So basically, to get the hypotenuse, you take the short leg times 2. And to get the long leg, you take the short leg times the square root of 3. Let's see if that's true. So this is a 4 by 4 by 4. The long leg was 2 times the square root of 3. The short leg was 2, and the hypotenuse was 4. So it looks like you're multiplying this times 2, and you're multiplying this times the square root of 3 to go this way, and times the square root of 2 to go this way. So this was a 6 by 6 by 6, and we got 3 square roots of 3, and this shorter leg was 3, and so then the hypotenuse is going to be 6. And then an 8 by 8 by 8, this would be 4 square root of 3. The shorter leg is 4, and the hypotenuse is 4 times 2, which is 8. And so that's the relationship that we're looking at. And if we look at the chart, you will see that. This is going to be the short leg. This is the hypotenuse, because it's across from the 90. This is the short leg, because it's across from the 30. And this is the 60-degree angle, so this is going to be the long leg. Okay? And you'll notice the short leg is labeled A. The long leg is A, which is the short leg, times the square root of 3. And the hypotenuse is 2 times A. Okay, so let's apply these rules, and we'll show you some example problems as we're going along. So let's look at number 1. So number 1 we know is a 45. It's going to be a 45, 45, 90. So that means that if this leg is 6, this leg is 6. And then the hypotenuse equals the leg times the square root of 2. And the legs equal A. They're both the same. All right, so number 3, we can look again. Well, now we're given the hypotenuse. So if we're going to set this up, it would be A squared plus A squared equals the hypotenuse, which is A to the square root of 2 squared, right? All right, just saying, just to let you know that how this is working out. So in this case, we know that A squared plus A squared is going to equal 3 squared. So A squared plus A squared, that's 2A squared equals 9. So I'm going to divide by 2. So I get a squared equals the square root of 9 over 2. And that equals 3 over the square root of 2. So that's what a equals. But, so we could say that a equals 3 over the square root of 2. Unfortunately, I don't know if you remember this from back in the day, you won't be held accountable for it in geometry, but I just want you to understand that you can't have a rational number in the denominator. So you multiply this by the square root of 2 over the square root of 2, and that'll give you 3 times the square root of 2 on top, and the square root of 2 times the square root of 2 is just 2. So the final answer, it's called rationalizing the denominator, is 3 square roots of 2 over 2. And that's what this would equal. And that's what this would equal to. Okay, for number 5, once again, you're going to do the same thing. A squared plus a squared, because we know these are both equal, is going to equal 6 times the square root of 2, and then you would square this whole thing. Now, I know the shortcut, and the shortcut is just this number in front of the square root of 2 is going to be the side length. So this is 6 and this is 6. But if you work this out, you would get the same thing. This would be 2a squared equals 6 squared is 36. And the square root of 2 squared is just 2. And so this is actually 2a squared equals 72. And then when you divide by 2, you end up with a squared equaling 36. And then the last step is to take the square root. So a equals 6. So you do end up there, but if you didn't know how to do that, you could just see that this number 6 is going to be what they both equal. All right, do the odds. Moving on, these are going to be 30, 60, 90s, okay? And so the special relationship we have to remember is that the hypotenuse equals 2a, the short leg is a, and the long leg is a times the square root of 3. So in this case, the first thing I would always do is call this is going to 60 degrees, across from 60 degrees, that's long leg, this is short leg, and this is height. So if the hypotenuse is twice the short leg is just going to be the hypotenuse divided by 2. So this is 5. And then the long leg is just going to be the short leg times the square root of 3. So this would be 5 square root of 3. It's that basic. And then you can convert that into a decimal if you'd like. You just multiply 5 times the square root of 3. All right, moving on. Number 9. This is a 60-degree angle. So I know this is the long leg, aside from looking at it. This is the short leg, and this is the hypotenuse, because it's across from the 90. And then the relationship I'm looking at is the short leg is 4. So the hypotenuse is going to equal 8, because 4 times 2 is 8. And then this is just going to be 4 times the square root of 3. Number 11, this is a 30-degree angle, so I know this is the short leg. This would be the long leg, and this is the hypotenuse. So if my short leg is 1, my hypotenuse is 2, and my long leg is 1 times the square root of 3. Okay, this is my long leg, and I'm just going to tell you to crisscross number 13 because I made a mistake by putting it on there. So number 15, let's go ahead and label our sides. So this is my hypotenuse, this is my short leg, and this is my long leg, okay? So if my long leg is 3 times the square root of 3 over 2, I'm just going to take that off. So my short leg is 3 over 2, and then my hypotenuse is 3 over 2 times 2, which 3 times 2 is 6 over 2, which is just 3. So my hypotenuse is 3. Okay, for the last one, again, this is my long leg. This is my short leg. This is my hypotenuse. Well, if my long leg is 4 times the square root of 3, if I just take the square root of 3 off, that will give me my short leg, 4. And then my hypotenuse is just 4 times 2, which is 8. Okay, so you are responsible for the even problems, and you're going to turn this in at the end of class for a exit ticket grade to make sure you know how to apply the rules for 30, 60, 90, and 45, 45, 90. If you have any questions, let me know.